All right, so as always, any questions?
Yeah.
Pop that out. All right, go ahead. Wait. Hold on. Wait. All right, go ahead. Okay.
8.7.
Hold on 1 second. Let me just get this drawing right here. I have right triangle ABC. This is leg A, leg B, leg C. All right, go ahead. Tell me about it. Okay. All right. Okay. So what did they give me in the triangle? Did they give me any legs, any angles? No? So B is 3, A is 7, and then they want to know what is C, right? All right. So I have A, I have B. How do I find C? What's that formula to find C? Go ahead, you can use a formula sheet. A squared equals, all right. So formula right here, which is on the formula sheet, we can use it, right? A squared plus B squared equals C squared, right? And then after that, just plug it in. You know what A is. What's A? 7 squared plus, what's B? 3 squared equals C squared. Do the math. What's that? 49 plus 9 is equal to C squared. And then what's this? 58, am I right? Is equal to C squared. What do I do after that? Square root both sides, get C by itself, right? So now I have C is equal to 58. What's that? 25, 26, 27, 28, 29. Can that get broken down? Think so? Into what and what? Because I don't know. I'm over here trying to figure out myself. I'm going to chop this in two. And what's that? That's 25, 26, 27, 28, 29. Can 29 get broken down again? It can't be broken down. So then it's just square root 58 then, if I can't break down to 29. All right, so that being said, we know that C is square root 58, right? So now what do I want? I want to know what is sine of A, cosine of A, tan of A, sine of B, cosine of B, tan of B. All right, what's the answers? And it's okay, go ahead. You can use your formula sheets. Go right ahead. No problem. You can use your formula sheets. What sine of A? Very good. 7 over the square root of 58. But remember though, I can't have those radicals in the denominator, right? So I have to rationalize. How do I rationalize that? By what? Exactly, right? Multiply this by square root 58 over square root 58. What's the final answer? Very good. Very good. All right, cosine of A. What's cosine of A? 3 over square root 58. Very good. All right, but you know it's illegal for me to have radicals in my denominator. It's got to rationalize that, so I'm multiply by what? Very good. Over square root 58. What does that equal? Very good. Over 58. What about tan of A? Exactly, 7 over 3. Right? What about sine of B? Mhm. Nope. 3 over square root 58. Now we're talking. Right? Right, for A and for B. So then now we have to multiply by so 58 over square root 58. So final answer is 3 square root 58 over 58. What about cosine of B? Very good. And then we have to rationalize the denominator. So I'm going to multiply by square root 58 over square root 58. Final answer is 7 square root 58 over 58. Tan B, what's that? 3 over 7. And that's it. Yeah. Plug it in. In what way? You plug in which ones? And this is 7 square root 58 over 58. So that's in the numerator, 7 square root 58 over 58. Not the way you typed it. It should look like this, 7 square root 58 over 58, like that. So like you should have the fraction, and then on the top, 7 square root, yeah, 58, and then down, and then do 58. Right? So 7 square root 58, right? Come out of the square root and divide it by 58, like that. Same way that I have it written. Yeah. So come out the square root and then do the division and all that. Yeah. Let's see. Y equals 3x minus 2x, like that. Yeah. This isn't completing a square. 3x minus 2x? Oh, okay, okay. All right, that sounds better. And then you want to complete the square with it? Okay. So like, is that like the A times X minus H K? Okay. So got you. Got you. So remember that we have this formula right here, right? We have our axis of symmetry, which is negative B divided by 2 times A squared. But before I could do that, real quick, remember that my A term, right, my A term has to be 1. How do I make this 1? I'm going to divide everything by 3. Everything, right? So when I do that, what do I get for my A term? I'm going to get, well, 0 is equal to x squared minus 2 over 3x, right? Now take that, plug it into the formula that we have over here. So this becomes negative times negative 2 over 3 divided by 2 times A, which is what? 1. And we're going to square that, right? So let's simplify that down. Negative times negative is positive. So that's like 2 over 3 times, this is like 2 over 1. So 1 over 2 squared, right? Now, if I want to multiply these out, right, these will cancel. This will give me 1 over 3 squared. Let's call that 1 over 9, right? When I have that 1 over 9, I'm going to add that to both sides of the equation. So plus 1 over 9 plus 1 over 9, right? A little bit of math on that. What do I have? 1 over 9 is equal to x squared minus what? Actually, wait, not even x squared. I'm sorry. Let me just go straight to the factor. This is going to be x minus what? Squared. Minus what number? Factor in the x squared minus 2 over 3x plus 1 over 9. What is it? Exactly. How'd you know that? Exactly, right? Take that number, plug it right there. That's it. All right? So anyway, back to the question that they want, right? Remember how I divided by that 3 before? Now I'm going to bring it back. I'm going to multiply both sides of this equation by 3. And then what do I have? So get a final answer. This is going to be what? This is like 3 over 1. Call that 3 over 9. So this is 1/3. Is equal to 3 times x minus 1/3 squared, right? And then you're going to subtract 1/3 from over here. What you do to one side, you do to the other. And then now, what do I have? 0 is equal to 3 times x minus 1/3 squared minus 1/3, right? So now, here's what I want. I have y is equal to a times x minus h squared plus k. Yeah, it's in web work though. They're gonna give it to you. What's a? What's h? And what's k? Tell me. Good. And what's h? 1/3. And what's k? Oh, close though. Negative 1/3. That's it. It's the whole problem. Any more questions?
Yeah.
Let me get that, then I'll get yours right after. X squared. Completing the square. And they want the AHK thing and all that. Okay. So first thing you want to do, isolate the whole number. So I'm gonna subtract 19 from over here. I'll do to one side, do to the other. So now I have negative 19 is equal to x squared plus 10. Go to the formula. By the way, this formula, 10x, you're right. By the way, this formula is on the formula sheet. So you don't need to memorize it. It's right there. Negative b over 2a squared. All right. Just plug it in. You get another color. This is going to be negative 10 over 2 times 1 squared, right? Call that negative 10 over 2 squared. Call this negative 5 squared. Call that 25, right? After I do that, you want to add that to both sides of the equation. So I'm going to add 25 here. I'm going to add 25 here. And when I do that, let's look at what I have. I have, whew, what's that, 6? Is equal to, what's this? Somebody help me. Plus or minus? Plus. Exactly. Right? Very good. And then after that, we're just going to solve for this over here. So subtract 6, subtract 6. So I have 0 is equal to x plus 5 squared minus 6. And then remember our formula? Y is equal to a times x minus h squared plus k. That being said, what's a? What is h? What is k? Good. What's h? No, what's h? Oh, h. What's h? Oh, what's h? Oh, what's h? Negative 5. Now we're talking. Very good. What's k? Negative 6. Perfect. Make sense? Negative 5. This 0 is equal to x minus negative 5 squared minus 6, like that. But a negative times a negative is positive. The reason why I do this is because the original formula is in x minus h.
Right.
So the minus is supposed to be there, but to turn the minus to a plus, you have to multiply by minus. The plus 5? That was, oh, from the factor up here. The x squared plus 10x plus 25. That's where that came from.
So that's what you took, on the rating that
So if you're looking for radian, you're gonna multiply by pi over 180, right? So you're gonna have a degrees answer, you multiply by pi over 180. It don't matter, each of them, pi over 180. So long story short, whatever you have there, divided by 180 and just put a pi next to it. That's the answer. It don't matter what number's there. Yeah, and then put a pi next to it. Behind it. It don't matter what the number is, just divide it, put a pi next to it. Yeah. So like if you have like 90, right? You divide it by 180, right? And then you multiply it by pi. So then the answer would be pi over 2.
So, Chris, did you do,
Okay.
you want,
What is it?
one,
Like this? So what I'm saying is to go from degrees to radian, right? Multiply by pi over 180, right? So long story short, what that means, you could just do 140 divided by 180, let's say pi. And when you reduce this, the zeros will cancel out. 14, what's that? 2 goes into 14 7 times, 2 goes into 18 9 times. So I would say my final answer is like 7 pi over 9, something like that. But your calculator can give you the 7 over 9. You just put pi next to it. 7 pi over 9. So yeah. It could be on the side too. If you wanna do a 7 over 9 pi, I'll take that answer too. That's fine.
so. Yeah, so,
Yeah, that's it. You can totally just do it in your calculator, and that's the whole question. Then if you want to go in reverse, you want to go from radian to degrees, right? You just multiply by 180 over pi.
two, Sean, and then 270.
Same thing. Negative 270 divided by 180. What is it? Do the calculator. You gotta do it.
270?
Yeah, negative 270.
Oh,
All right, so change that into a fraction. Like a improper fraction. Yeah. What is it? Huh? So whatever answer you get, just put pi next to it. That's it. Yeah. 1.5 pi. Change it into an improper fraction. Yeah. Just use the fraction button. There's literally a button on the calculator that does that. That's it. 3 pi over 2. Yeah. What you got? Just solve for x. So the issue that you have with this is that square root. Wait, say it again? Like that? Well, that's even easier. That's nothing. Just so the issue you got is the radicals, right? Just square both sides. Just like that. So now you got what? 2x plus 2 is equal to x plus 5. Throw your numbers on one side or your variables on the other. So I'm going to subtract x from over here while I do the one side do to the other. I'm going to subtract 2 from over here while I do the one side do to the other. And what do I have? X is equal to 3. That's it. Yeah. Yeah. Got you. And then, you check it, plug it in, see if it works and whatnot, and that's it. Yeah. It's good, man. Huh? Okay. 2 squared? Or t squared? Like lowercase t? Okay. All right. And you want to complete the square, right? So what you're going to do, you're going to add 1 over here, which you do to one side, do to the other. So I have t squared plus 3t This one. This is on completing a square. So I have this formula here, right? Negative b over 2a squared. My a is 1 in this case, so that's good. So I can just go straight ahead. So this is like negative 3 over 2 times a, which is 1. The negative, the formula. So then this would be like what? Negative 3 over 2 squared, right? Yeah. And then that's just 9 over 4, right? And then you want to add that to both sides. And then you factor it. What's that? 13 over 4, something like that. Because 1 is like 4 over 4, and 9 plus 4 is 13 divided by 4. So what goes in here? T what? Plus or minus? 13 is like 4 over 4 plus 9 over 4. You see the 1 plus 9 over 4?
Yeah.
I rewrite the 1 as 4 divided by 4. Add across. Because remember, you have to have the same denominator in order to add. So what goes there? No, close though. Say it again? Not 3t. 3 over 2 plus 3 over 2. Right? Mm-hmm. Because because you're squaring it, a negative times a negative is a positive. Yeah. You typed it in just like this? That's why. And that's that. And then, A, H, K, all that good stuff. Yeah. It's gonna give you a quadratic and ask you to solve it. It's not gonna tell you how. Do whatever you like. Well, when I say quadratic, I mean like any polynomial that's of degree 2. So however it looks, relevant. You add it to both sides, yeah, always. Then you're gonna factor one side and add it to the other, and then boom, that's it. If you wanted to say you were trying to do this on the test and you wanted to solve for t, you would just square root both sides and then subtract the 3 over 2, and that's it. Yeah. This is a homework question. They're looking for the AHK. Was everybody else done with the homework? Yeah, I'm still working. Typing it in. You can try it as many times as you need, like no pressure, no penalty. Yeah. Got you. Yeah.
Even the third.
No pressure, no penalty.
Yeah. He was just like.
Yeah,
He's kind of stuck.
He kept on trying it, yeah.
Ooh, that's a crazy question. All right, we can do that. So same thing, completing the square, this next question, right? This is 9x squared plus 18x. What was the last part?
I agree.
16?
Yeah.
Okay.
Minus.
So same thing, completing the square, right? Your first goal, isolate the constant term, right? So I'm gonna add 16 over here. What I do to one side, I gotta do to the other. So now I have 9x squared plus 18x is equal to 16. Let me try that again, hold on. Is equal to 16, right? Now, I want my a term to be 1, right? So the only way to turn the 9 into a 1 is to divide by 9. But everybody gets divided by 9, right? Yeah. This will cancel out. So I have x squared plus 2x is equal to whatever 16 over 9 is. I don't know what that is, right? Then we go straight to the formula. We have what? Negative b over 2a squared. Just going to plug that in. So it's going to be what? Negative 2 over 2 times 1 squared. So what's that? Negative 1 squared. So that's positive 1. And then now I'm going to add 1 to both sides. So what do I have now? It should be x what? Wait. What am I talking about? I'm over here. I'm on the other side. 16 over 9 plus 1. What's that? One. 25 over 9. Very good. Remember, the 1 is like 1 over 1. So I need the same denominator. So it's like 16 plus 9 divided by 9. So 25 over 9.
Oh. I do.
That. All right, but what's the factor though? Sorry about that. Excuse me. What's the factor? So I have x in the middle right here, right? What goes there? Plus or minus? Plus. And then what's the number? No. 1. And then that's it. You know? Yeah. Did they want like a AHK, or they just asking for the answer to the question? They want the answer to the question? All right, so to solve for this, right? I would square root this, but what I do to one side, I gotta do to the other. Square root and the square cancels out, leaving back x plus 1 is equal to square root of 25, what's that? 5 over square root of 9 is 3, right? So, but not just that, plus or minus, right? It's in front of it. And then we want to subtract 1. So x is equal to, yep, negative 1 plus or minus 5 over 3. Now, in order for me to put this together, you already know it's going to be negative 1 over 1 plus or minus 5 over 3. This has to be multiplied by 3, whether it's the bottom or the top, right? So this equals negative 3 over 3 plus or minus 5 over 3. Right? And we're gonna have two answers from there. One answer is gonna be -3 over and what's that? That's like -8 over 3. That's one answer. The other answer is the plus, so -3 plus square, yes, well, plus 5. Right? Sorry. Supposed to be plus 5 over 3, right? -3 plus 5 is like what, 2, I think? All right, so this should be 2 over 3. And so these are my answers here. And just separate them by a comma. What? That's completing the square. Go ahead.
So vote for the answer.
Cool. I mean, you should check it. Yeah.
The negative is got the plus one,
Uh-huh.
the -5,
The negative, if it's higher,
-5, that's the plus one. That's how you have to the -5.
yeah. Yeah, because that looks like +5. Right? So like, no matter what degree they give you, it don't matter, right? To go from degrees to radian, yeah. That's it. Just multiply by pi over 180. In your calculator, very simply, you can just do 350 divided by 180. Zeros will cancel. 5 goes into 35 7 times. 5 goes into, is it the right approach? Hold on. I don't know. 17 over 9? 5? Something like that. It's what? 535 pi over 18. Huh?
Oh, yeah, it is.
It's 350 degrees to radian. That should work. 35 pi over 18.
Yeah, that's the 17 over 9 is 340. I did.
Yeah. 35 pi over 18 should work.
It's wrong. Yeah.
I was trusting the calculator. For me, I see 350 and I see 180, and all I want to do is just kill zeros. Call it 35 pi over 18.
It's wrong.
You can just leave it like that. As long as the computer takes it, that's all that matters. Huh? Went through? Got you.
Is it negative? Oh, that's.
Ready? I'll let you. You have another question?
So we got that.
For which one?
Mhm.
The radian one?
Yeah,
What was it?
negative 270.
So negative 270 degrees times pi over 180. Yeah, kill the zeros. Yeah. And then 9 goes into 18 twice. 9 goes into 27 3 times. So negative 3 pi over 2. That's it. The point is, all your questions, divide them by 180, put a pi next to the answers.
On the final, do you say that's this question, read the rating?
This is Ingles, I think. Like 5.1. Oh, what was it?
Yeah, it's 5.4, right?
I'm not sure.
Yeah, 5.1.
Yeah.
Oh, so on the final, it's gonna act, what is it, be the rating? No, it's not?
I just want y'all to say y'all saw.
It's not gonna act for computing and square either, it's gonna give you.
You get a quadratic, just answer it. Just give me the answer. That's it. However you want to do it. You want to use the quadratic formula, go ahead.
Now, the computer is doing that. It's small.
Why?
Doing it right. Like,
Just copy.
for one, I feel like I'm doing it the wrong way.
So then just copy.
So like I did it.
Oh no. These questions are specific, that's why.
I like it.
Got you. Mhm. Alright. So let me run through this lesson real quick. I'll be quick. I promise. Now, this is something that we actually already started. So you might be able to just like look at it and be like, yeah, I know that already, you know?
Finals here.
Hmm? On Thursday. Yeah, the final should be like real nice, real simple, and crazy. It's in the 20s. It's either like 21 or 22, something like that. It might be 23 if I'm off, but it's in the 20s. So you can use what you have, but I'll give you something else. It's the same final from like the Math 28 class, so I figure just like give y'all a review sheet from that. So today I want to talk about depression. All right. I don't want nobody to feel depressed on the day of the final. So let's talk about depression for a little bit. Those of you that took psychology, y'all know where I'm going with this. All right? Yeah, I'm serious. All right. So we're gonna use right triangle trigonometry to solve applied problems, right? So right triangle trigonometry has many practical applications. For example, the ability to compute the length of the sides of a triangle makes it possible to find the height of a tall object without climbing to the top or having to extend the tape measure along its height. We do so by measuring a distance from the base of the object to the point on the ground some distance away, where we can look up to the top of the tall object at an angle. The angle of elevation of an object, right, is above an observer relative to the observer is the angle between the horizontal and the line from the object to the observer's eye, right? The right triangle this position creates has sides that represent the unknown height, the measured distance from the base, and the angled line of sight from the ground to the top of the object. Knowing the measured distance to the base of the object and the angle of the line of sight, we can use trigonometric functions to calculate the unknown height. Similarly, we can form a triangle from the top of a tall object by looking downward. The angle of depression, right, of an object below an observer relative to the observer is the angle between the horizontal and the line from the from the object to the observer's eye, right? So, blah, blah, blah. Let me show you what that looks like. This picture will like clarify all of that. All right. So check it out. Let's say that we have a Eiffel Tower looking structure right here, right? Right. Go Team USA. Anyway, right? So we have the angle of elevation, right? So if I'm standing right here, right? I'm looking up, that's elevation, right? Depression, I'm standing right here, and I'm looking down, that's depression. That's it. All right. If you're looking up, elevation, you're looking down, depression. That's simple. Hmm? Yeah. This is an actual application. So, but before we even like jump into an example problem real quick, let me just tell y'all how we do this real quick. All right. All right, so here's a little notes, right? So given a tall object, measure its height indirectly. Make a sketch of the problem situation to keep track of the known and the unknown information. Lay out a measured distance from the base of the object to a point where the top of the object is clearly visible. At the other end of the measured distance, look up to the top of the object and measure the angle of the line of sight it makes with the horizontal. Write an equation relating the unknown height, the measured distance, and the tangent of the angle to the line of sight, and then solve the equation for the unknown height. Cool, right? Awesome. So let's take a look. All right. I'm sure Simone Biles does this like every night, right? So, oops. So we're measuring a distance indirectly. So to find the height of a tree, a person walks to a point 30 feet from the base of the tree. She measures an angle of 57 degrees between the line of sight to the top of the tree and the ground as shown in this picture here, right? So what do we want? We want the height of the tree. Like how tall is this tree, right? So let's think of it like this, right? Let's say that this is the height right here, h, right? There's some kind of trigonometric function that I could use to get this answer, right? What am I going to use to get this? Like, how can I solve for this? Somebody tell me. Not length times height. No. I'm looking for like a sine, a cosine, a tangent. Like, give me something. Yeah.
over height.
But which one am I doing though? Cosine? All right, cosine of what angle? All right, so let's look. So cosine of 57 degrees is equal to what over what? All right, so what's the adjacent here? No.
30 is the
30 is the adjacent, so 30 over what? I'm gonna just call this C over here. So it'd be like 30 over C, right? This is good, but it's not what I'm looking for, right? So I actually wouldn't use cosine because it doesn't give me the answer. So give me something better. What is it? No, I can't use that. I need to have two sides in order to use that formula. Right, but there's another trig function could work here. Tan, I like that. So let's see, tan of 57 degrees is equal to what?
opposite, which is height.
Okay, so H over 30 exactly. Now we're talking, right?
So 30 over C would be.
No, it wouldn't. Because remember, all I want is H. I don't care what C is. Yeah. So now, that being said, to get the H, multiply by 30 degrees over here. What you do to one side, you do to the other. So what's my final answer? 30 degrees, tan, 57 degrees is equal to the height of the tree in feet. Rest of that is calculator, so that don't even matter. Do we get the idea here? So I pick a trigonometric function, sine, cosine, or tangent, one of them three, right? And I solve for whatever it is I'm looking for, right? In this case, I want the height of the tree. That's it, right?
So that would be H.
That'd be H. 30 times tan 57 degrees. Straight calculator. That's all that is. Yeah. Yeah. Go ahead. Because that's what they gave us in the formula or in the drawing. So this lady, she walked 30 feet away from the tree. So that's the 30. Well, that's the adjacent, but I want to know what is the height of the tree. Like I want to know how tall this tree is. Yeah. So I use the 30 feet that she walked and the angle of elevation, right? Because she's looking up at the top of the tree. You know? And then boom.
If I get the depth,
It's gonna be a decimal, yeah.
Oh.
Yeah. So H is 30 tan 57 degrees. Okay, I'll take it. I heard 46.195. 959. Okay. Yeah. I don't really care about the answer here. I just wanted y'all to see that.
10.
Yeah, 10. Yeah, whatever the answer is, I trust y'all calculators.
The,
That's it.
in the final, can you actually put it?
No, it's not on your final. I want you to see it though.
You said we could do it?
It's an applied thing. What answer you said you got?
46.19.
Yeah, that's good. 46.2 I would get on the calculator. So this is like that extra question that you guys saw on the review sheet with the word problem. That's what this is right here. I'm gonna let you guys try one. No picture though, but I'm sure y'all could get it. It's literally the same kind of thing. Same thing. That's everything. Perfect. 30, 10. Um, we have all this stuff here. You should. This one is what's it called? It's so distorted. Something wrong with the screen on this calculator. It shouldn't be like distorted like this. Which is fine, but see, when you type things here, it's not clear. Scaffold needs to change. Yeah, this is old. So, what you do, man, the $20, the 36 Pro, the ones, not them, those are like $200. It's one little black one that he got, that one. Not him. Ronnie. $20. Yeah, can't beat that. That little calculator, it was good back in like the 90s. Now they have more advanced ones that can do so much more. Yeah. Just get that little one and just come a tutor and then we'll work with how to use it. Yeah. All right, where's everybody? Y'all tried this? All right. Let's take a look. So, how long of a ladder is needed to reach a window that is 50 feet above the ground if the ladder rests against the building, making an angle of 5 pi over 12 with the ground, right? And then round to the nearest foot. All right. Don't judge me right now. Not that good at art. I tried it in high school. Not my forte. That joint is hard. Yo, I was about to do that too, man. Like I'm trying here. I'm not even gonna lie. Like I'm trying to remember how you draw a ladder. Is it like this? I don't think it's supposed to be turned that way. It's something like that. All right, so now I got some angle right here. This 90 degrees right here. Yeah, the 5 pi over 12. No, that's radian. So what I gotta do, right? I want to switch from radian to degrees. Oops. Right. Degrees. I can't spell. So I have 5 pi over 12 times 180 over pi. Very good, Ronnie. Pi's get canceled out, right? But reduce this a little bit. Oh boy. What's that? 6, that's 90. That's 2, that's 30, that's 1, that's 15, right? Something like that. So 15 times 5, what's that? 30, then 30 and 30 is 60, right? It's another 15. Right, what's that? 75? Y'all should check me on this. Y'all know I'm not that good at math. What's 15 times 5? Oh no. 15 times 5 is 75. All right, so that's what I got, 75 degrees. All right. I want to know how much ladder do I need, right? Right. And what I know is that the bottom of the ladder, wait, how much ladders need to reach the height of the window? Yeah. Yeah, that's 50 feet right here. All right, so the window is 50 feet high. How much ladder do I need to reach that window? All right. You tell me. So you want to use cosine? So cosine of what angle? 75 degrees is equal to what? What's that? X over ladder? That don't help me. Give me something else. You want to use tan? All right, let's use tan. So tan 75 degrees is equal to what? What's tan? Opposite over adjacent. So what is it? 50 over X, right? That's not what I need though. 50 is the height of the window. Yeah. That was given to us in the problem. All right, so give me another one. Sine, now we're talking, right? So sine of 75 degrees is equal to what? Yeah, so what is it? Not 75. 50 over what? Over ladder. That's it. Right? And then just solve for ladder, right? You kind of just switch them. So the ladder's height, or whatever you call it, is equal to 50 divided by sine 75. That's it. The rest of it is calculator. Y'all could do that.
Yeah.
Yeah.
Something about a cold,
Mhm.
how much sand is dropping.
While it's
over.
yeah.
How do I know?
I mean, you just figure it out. No lie, your whole major is that though, like these types of questions. Like this whole section of the class was for you.
Like word
Like,
problems.
yeah. All right, so that's that. All right, sure.
I got 51.
Scroll down. Like, you'll make it smaller. Like that. Yeah. So now,
So none of this is gonna be
oh no, that's not fine. So now we can prepare for the final. Couple ways to prepare. Finish all the homework. I'm gonna give y'all a review sheet tonight, tonight. I'm gonna give y'all a little review practice final that y'all could do on web work. All right? And then that's it.
So tomorrow we're gonna straighten
Yeah.
whatever.
Tonight, if you guys want, y'all could huddle up and do some homework together. Y'all want, take out y'all computers, like, if you wanna use this, go ahead.
Right now.
Yeah,
This is it? That was the lesson?
yeah, that's it. Yeah,
That's a little fix it. You learn in
Yeah.
5 minutes.
yeah. That's all it is. So let me, yeah, I mean, the homework's there. Just let me know when I can, drop this down. I have to take it down? Alright. Alright.
I'm gonna have to watch the video, like, keep the videos up first.
Yeah, I got you. Alright, so I'm gonna take it down. Take it down. Oh, no, I won't. I'm gonna keep it.
Then if you just come to class, you like, look at the video after you did this lesson. Oh, watch